Everybody hear me okay? Yeah, there we go. All right, so it feels like every time in the past several years I've been up here presenting on repeaters and those things. So today we're going to do something a little different. Today's going to be focused on kind of one of the aspects of the hobby that I really enjoy, DXing, and what kind of my journey has been over the last 10 years to improve my station, to improve my DX stats and the chasing and all that. So I think probably 99% of the folks here and online know me, but James Isaac, KI0KN, I'm the NCRC Tech Chair. Go ahead and advance, Dave. So, I sit on a couple of boards for some ham and some non-ham 501c3s, the section emergency coordinator for Colorado ARES and Oxcom. And really out of all the aspects of the hobby, which I participate in a lot of, my absolute two favorite are DXing and summits on the air. So those are some of my favorite pieces there, and today we're going to talk about the DXing aspect. Anybody that chases DX, this is where my current standings are in chasing. So if you're into DXing at all, you'll know that currently there are 330 possible entities to work them all, if you will. I'm at 282 at the moment, and slowly working my way up there. I had two accomplishments this calendar year so far. I finally crossed 1,000 points in challenge. So DXCC challenge is working 1,000 band slots. And then I also finally worked zone 32 for my worked all zones. I worked Libya the other day for zone 32, which is what I was missing. Okay, so let's talk about the twisted. What's that?
What countries did you work
On
on?
I'd have to go look. I don't.
Three up there.
Three up there.
U.S., Canada.
Those were probably satellite. So, So, both kind of a sad, maybe an ironic story. My first DXCC, I actually worked entirely on satellite only. I had 107 countries with QSL cards confirmed, and I moved. And before I had the chance to send them in and get my DXCC award, my basement flooded and destroyed them all. So that number 3 right there is actually like closer to 110, but I lost all the cards and couldn't do it. So, okay. So the twisted art of DXing. If anybody is done this chasing or is after that entity or something like that, 3 a.m. your phone goes off or you set an alarm, you got an alert for that you've set up, so you run down to the shack to fire things up. So maybe not everybody does this. I don't wait till 3 a.m. up. I sleep until 3 a.m. then run to the shack. Go ahead. And so why do we have to be quick to get some of these DXs? There's a whole bunch of reasons. So gray line is that, they'll if you look at gray line in the test questions for your test, they'll say it's maybe a 30-minute window that where when your sun goes up or right as the sun goes down, to where you'll have this area where the ionosphere is still ionized over the area, but the sun is down, so the noise source is lower. I will tell you that gray line might last 30 minutes. Gray line might last 2 minutes. It really depends on a million different things. So there might be a short gray line window to a really hard to get place that you want to run to get. QSB, the signals are fading in, fading out, so you might have to work somebody while it's faded in your spot. You never know when they're going to, let me go back one. You never know when a DX station or a DXpedition is going to change frequency or quit. You might have spot propagation. I've experienced this. There's a bunch of really big Colorado DXers that live down They call it RF Alley. It's down southeast of Denver. There's a big ridge down there that a bunch of them live on that just seem to be the hot spot of RF. You can work the whole world there all the time. We've had points where they can hear something and I can't here in Loveland, and I've had points where I can hear them, and those guys with the monster stations down there can't hear anything. It's because it's just like a spotlight of propagation. And then this one, every once in a while, you may get lucky. A DX might be checking a new band to see if propagation's open, and you might be one of 10 contacts they make on that band before they decide to move on. You just got to be right place, right time. Good. So as I've decided to improve my chase, I decided before I just started throwing things at my station, I wanted to build some goals to meet, to work towards to do that. And so these are some of the efficiency goals that I had for my station. I wanted to really make sure it was a very low noise, because you're often working with very low small signals. I wanted to have flexible receiving options, vertical or horizontal, or incoming angle of radiation, and have multiple things. Flexible transmitting options, because I've had that situation where you can hear them great, they can't hear you, but you switch transmitting antennas and all of a sudden they can hear you. And then it had to be 3 a.m. idiot proof. When I launch out of bed because of a text or an alarm, I want to go downstairs, I'm bleary-eyed. I don't want to transmit into an out-of-band antenna or into the second radio, so the station has to make sure none of that can happen for me. The other one is making sure that the station does everything I need, so I don't have to remember to adjust 10,000 knobs and buttons and switches. I want to be able to QSY between bands, between top to bottom of the band, if they go from CW to voice or voice to CW. I don't want amplifier warm up, and I want my station to follow me. So if I change, I want everything to change with me. I want the antennas and the amps and the bandpass filters and everything to change automatically for me, including the rotors and what I'm using to do it, whether it's a key or a mic switch or whatever. So, step one, how are we going to keep step one in making sure this happens is making sure that everything you're transmitting into stays resonant at 50 ohms. So my station is what I consider a no-tune station. I do not use a tuner. I have one exception, I did lie about that. I do not have a natively resonant 60 meter antenna, so I have to tune something out of band to 60. But everything else, 6 through 160, is no tune. And that means that the antenna is either natively resonant and widebanded enough to cover the whole band, or the antenna must be able to be adjusted quickly to a new resonant point so that you can use it without having to hunt and search for tuning. Here's the easy way to do it. Okay, it's kind of the expensive way to do it, but this is the easy way to do it on the higher bands. This is a step IR antenna. This is a DB36. If you're not familiar with step IRs, what you see here, each one of these elements is a fiberglass tube. It's a nested set that gets smaller as they go. And these black boxes on each one of these has a stepper motor in it that drives 2 reels of punched copper tape, and the tape runs out into the fiberglass tubes. Well, when you have that infinitely adjustable thing, you can make a perfectly resonant antenna by adjusting the length of each of those elements. So it's resonant natively, and it can be widebanded, because if you're at the CW section and you need to go to the sideband section, it just pulls the tapes in an inch or two and it retunes the antenna just a little bit. So this antenna is incredibly effective. It's 4 elements on 6 through 20 meters, and then it's 3 full elements on 30 and 40 meters. And these, they call them trombones at the end, it actually becomes a folded dipole on 30 and 40 meters. They partially fold back over onto themselves so that you still have a full-size element, but it is not. At 30 and 40 meters, the element lengths become incredibly long, so that's how they manage the size.
What's the boom length?
Boom length is 36 feet, and I think these are 54 across. So it's
The biggest thing in my neighborhood.
They're pretty big. They're big wind targets. You can see there's trussing all over it to hold everything up. Bob?
Which one's the driven element? Is it the single?
The driven element's right here. It's the one that's a little bit longer. It's got an extra 10 foot of pipe in there. So this is the driven. But that's the only element that always stays the driven. This antenna can operate in both directions. So this can be the reflector driven, director 1, director 2, or you can operate it backwards. And this is director 1 driven, reflector 1, reflector 2. So it's a really flexible antenna, and it's got some interesting, it's all computer modelized. These little guys right here and here are passive 6 element, 6 meter elements. So in 6 meters, it's actually a 6 element beam. Go ahead, Dave. And so the controller here kind of shows you what the antenna is doing. Currently, we're in the normal mode. You can see that it's basically about 13.5 dB gain, and it's got a 31.6 dB front to back ratio with a beam width of about 55 degrees. That's all figured out from computer modeling when they designed the antenna. Now the other way you can get a natively resonant antenna is by using a full-size beam, one that's not loaded at all. This larger one that you see up here is it used to be Bencher Skyhawk Tribander. It's now DX Engineering bought them. So that is 4 elements on 10 meters, 3 elements on 15 and 20 meters, but they're full-size elements. That's actually a half wavelength, basically, dipoles up there. Below it is a 4-element, 6-meter beam, also full-size. So those antennas are natively resonant because they're full-size and they're very wide bandwidth. So it covers each of those bands end to end with no tuning. But we start talking about 30 meters and down, and we have some new challenges because the physical limits of building antennas at full size like that become, a quarter wave antenna at 160 meters is 132 feet high. That becomes a little bit of a problem. It's not impossible, but I think, the wind blows, the ice, the snow, anything else like that, it becomes very unruly. So we can't really use full-size antennas at these longer wavelengths. So everybody knows, how do you handle that, right? We make shorter physical antennas that are electrically longer with loading of some sort. They're either base loaded with inductance, top loaded with capacitance. They might be linearly loaded. But what's an inherent characteristic of an a physically shortened, electrically lengthened antenna? Bandwidth. Their bandwidth starts going down. They become higher Q antennas, and our bandwidth, so we no longer can cover that whole spectrum from edge to edge of the band. So we got to do something about that. Go ahead, Dave. This is my 160 meter antenna. My quarter wave, I mentioned, is about 132 feet. This antenna is about 72 feet high. And it has, if this is guy lines here lower, these top ones are T-loaded it's a capacitance hat. There's about 32 foot of wire up there, 14 gauge wire, adding capacitance at the top of the antenna to bring the antenna resonant into the 160 meter band. But it's got a very, very narrow bandwidth because it's so short. So how do we fix that? Well, you could use a tuner, but I said back in my original goal, no tuners, right? Tuners take time and they use up, especially if you're chasing a DX. Anybody that's chased DX, or even if you haven't, if you're listening on HF, you hear people tuning up. People are incredibly rude on the HF bands. They tune all over the top of everybody, and you just hear and you'll hear it. The signal's stronger and weaker as the tuner is seeking a match. It also takes time. So the way I deal with it is by adjusting the resonance of the antenna. And the way I do that is by adding inductance or capacitance to the antenna at the base of the antenna. Because this antenna is natively resonant at 160 meters, I need very, very little. So, instead of tuning, like a 43-foot non-resonant vertical where you need lots of inductance, this just needs a teeny little tweak to move it up and down from its resonant point. And I do that with a set of relays back here. There are 9 relays back here that switch taps on the inductor, and that inductor is 1/4-inch copper refrigerator water line wound around, I don't know, about a 3-inch form. So my antenna is resonant. If I want to tune it lower in the band, I add inductance by switching in taps on this coil. If I want to tune it above its resonant point, I switch in these silver mica capacitors here. And that allows me to slightly shift the resonant point of my antenna up and down the 160 meter band. I have a smaller version of the same thing on my 80 meter antenna. The 160 meter antenna has 9 taps, the 80 meter has 3. Good, Dave. So I'm going to talk a little sidetrack here. I want to talk about this because we hear about this all the time. Resonant frequency does not mean best SWR at 50 ohms. Here's an example. That antenna I just showed you, my 160 meter antenna, it is natively resonant at 1.845 megahertz, but at 12.5 ohms resistive. That at our 50 ohm load presents about a 4-to-1 SWR, so it's unusable as is, even though it's resonant right in the middle of the band. So how do we take care of that? This is a 1-to-4 current unun down here that's wound. It's a double core. It's wound with RG400 coax. And the reason is 160 meters loves to arc. It's a very arc-friendly band, arc-happy band. So you got to use high voltage dielectric coaxes. I use the double cores for the power handling. This converts my 12.5 ohms to basically about 50 ohms. So now my 1.845 megahertz 12.5 ohm antenna is actually, is now natively about 1-to-1 at 50 ohms. So it's just a current transformer. This is a really important one, located at the antenna. So if I were to put this transformation in the shack, and so what is this thing doing? Your tuner does this same thing. If you have your tuner and your tuner's in your shack, yeah, your radio is going to see a beautiful 1-to-1 SWR. But the coax, which is a 50 ohm coax, has got it's talking to an antenna that's 12.5 ohms. You're going to have a tremendous amount of loss on the coax. So it's really important to keep this at the antenna for the lowest loss. Good. If you want to learn more about baluns, ununs, impedance transformation, the losses associated with doing this, how to do it the lowest way, this book is indispensable. I highly recommend it. It's an old book by Jerry Sivik, W2MI, and you can get it at the League, you can get it on Amazon, you get it all over the place. This book has the most amazing things. You can look it up and say, I need a 37-to-1 impedance transformer. There's going to be instructions in there on how to build it and show you the charts. So little sidetrack there on impedance and things. So the next step in building our station for efficient DXing, common mode currents are a really big problem. They introduce noise, right? So we got to fight common mode currents, and common mode currents are RF flowing on the shield of your coax instead of the center where it belongs. So you'll notice, how do I deal with this? I deal with it in multiple ways, but there's some simple ones you can do for every antenna. Every antenna I have has a 1-to-1 choke, an effective 1-to-1 choke right there at the antenna. That forces the currents equally back into the ground field there instead of riding back on your coax. Go ahead. That's the 160. This is the base of my 80 meter vertical. There's another one. There's a 1-to-1 choke right at the base of the antenna, feeding the antenna. This is a 40 meter quarter wave vertical I have. Again, it's, they're all in different forms and things like that, but they're all performing the exact same function. They're just 1-to-1 chokes. that keeping the RF off the shield of the feed line going back to the shack. Even my beams have them. This is that Skyhawk up there, and it's hard to see, but right along here there's a long tube. I think this one might be a bead balun. The other ones were wound on ferrites. This one I think is a piece of coax in that PVC with ferrite beads lined all along it. The Step IR has the same 1-to-1 balun built into one of the driven element housing, and the 6-meter beam has one too. Now the other piece that helps, if you can, keep your feed lines underground from the antenna back to the shack. Now, you'll see in my station I use PVC. There's a lot of folks that this is a Ford Chevy argument, whether or not you should run your feed lines in PVC underground or just direct bury them. It doesn't matter from a perspective. I mean, if they're underground, the same function is happening. There's arguments that water gets in there and the feed lines aren't meant for, underwater. They're meant for underground. In 10 years of being there, I've never had a problem with it. Doesn't mean that there won't be. I chose to do it this way because it was flexible and easier. But if your coax is underground, it gives any RF that might be on the shield an easy chance to bleed off into ground, and it also keeps RF from landing on the coax because it's underground. So it helps keep the common mode down a little bit. The other piece that's really important, your coax is not the only piece you have to worry about. If you have rotors, if you have antenna switches, if you have preamps out there, if you have any kind of device outside nearer the antenna that has a control line, those wires love to pick RF up and bring them back into the shack. Causes noise. So every single thing I have, rotor lines, antenna switches, all that stuff, they come through, and there's bypass capacitors on every line to ground. And I usually use 2 capacitors. I think it's a 0.1 and a 1 microfarad to ground on every one of those, just to bypass any RF that might be on the control line to ground before it heads into the house. You'll also see that, and there's a picture coming up, but up in the top corner you'll see the ground braid. Everything, I think everyone's heard about making sure that ground, everything is bonded together throughout your whole system to keep your ground potential the same. Everything in my system is bonded together. All the entry boxes, the towers, the same ground comes in and ties around a common ground around I have a 3/4 inch copper pipe around the backside of my operating desk that every piece of equipment is tied to. Go ahead. And that keeps everything together. So common mode is one source of noise, but it's not the only source of noise. So we need to start addressing all of the other sources of noise that might come in and bury a DX signal. I use the same type of feed line to my antennas, my HF antennas, as we use on the repeaters. Most of mine are LDF4, they're Heliax lines, and the first question I get about this is, wow, is that not the most expensive thing in the world? I'll tell you what, I bought a 350 or 400 foot roll of half-inch Andrews Helia, or I don't remember who this. It was a cutoff. I'm pretty sure the guy worked for a cell company, and they sell these chunks. They buy them in 1,000-foot or more rolls, and they sell these couple 100-foot chunks. I bought a 350 or 400-foot roll at something like 20 cents a foot. But you can find this stuff. I think brand new, it's under $2 a foot. So it's really not this massive difference than coax. Everyone thinks it's so expensive. It is as you start to increase the size, but half-inch feed line at HF is almost lossless across the entire HF band. So, hundreds of feet of this stuff does not matter. It's tremendously effective. And why I use it, go ahead, Dave. Here's the main reason I use it. If you look at the jacket, not the jacket, but the shield, you'll see that is 100% coverage. There is no holes in that shield at all. if you look at coax, even a double braid like this, right? You can see the dielectric through the holes, right? There's even some of the best coaxes have holes. Well, what do holes in your shield allow? They allow signal out and they allow noise in. So if you can eliminate as much of that as possible by going to something like this, not only do you get the advantage of the low loss, so much of your signal, but it's another noise elimination method.
How do you terminate that stuff?
The termination is ridiculously easy. So they're all mechanical. We don't solder them or anything typically. There's tools, and so you can spend hundreds of dollars on an automated stripping tool that runs on your drill, or for about 20 or 30 bucks you can buy a hand clamp that you just turn on and spin it, and it preps everything for you. You put the cable on, you put the O-ring on, you put the halves on, and 2 adjustable wrenches, and you're done. So they're very easy to use, Dick.
You can pin connectors on that?
So I'm going to get to that. I am not currently, right? End connectors would be the best. But how much of our ham gear has end connectors on it? Nothing, right? PL2, yes, I know, everything Doug owns has an end connector. End connectors would by far be the best option, but they're so then you come into the issue with, if you put end connectors on it, you have to convert it to PL259, SO239 on each end, and then so to me, if it's outside, that's one more mechanical piece and one more water entry point. PL259s are not waterproof, so I just put PL259s on all my HF stuff. I use ends on everything else, VHF and UHF up, but on the HF, I use PL259s because it's just easier to. So here's an incredibly popular cable, LMR 400. I do not own a single inch of this cable anywhere in my station. And why? HF, we're talking noise, right? So noise is a problem everywhere. But we're talking about, if you look at the signal to noise ratio of an HF signal versus a VHF repeater signal or something coming from town, our margin is so tiny at HF. Well, if you look at this cable, and this is good cable, right? But there's a problem in the construction of this cable that makes it really poor choice for HF. It happens to be the same thing that makes it a poor choice for repeater usage. This is tinned copper. This is aluminum foil. What happens when you put dissimilar metals touching each other? Corrosion is a problem, and noise is a problem, and noise from corrosion is a problem. You're basically making a diode contact there, and any movement in this cable or any corrosion in the cable generates a lot of noise. So, like in VHF, UHF, it's not a big deal because you're transmitting through the cable, then switching to receiving, coming back. But in repeater usage, we're transmitting and receiving on the cable at the same time. Believe it or not, that cable is vibrating at this frequency that you're using, and that is enough to cause noise with the shields and those 2 shields running. Well, on HF, even though we're not transmitting and receiving at the same time, we're still trying to receive something that may be fractions above the noise floor. So if we're adding noise to our signal in any way, we might wipe it out and miss that DX contact. Yeah, multiple stations. It's same problem, right? Because you're picking up strong RF from a nearby source. So I recommend you do not use LMR 400. And so, I just mentioned I use LMR, or I use, hardline is the wrong term. It's Heliax feed lines. But that is not super flexible stuff. So I do have coax for my rotor loops, and the small jumpers from the end of the stuff at the tower. Personally, I typically use Davis Berry Flex. It's a personal choice, but it's all copper, right? Everything's pure copper in the cable, so I don't have the dissimilar metal thing. Any quality RG8 cable is fine if you don't use the dissimilar metals. I mentioned earlier in the slide about keeping that ground potential the same. You can see that here, it's kind of buried, but in this one, there's a ground braid on this back plane. It goes through here and it talks to the, or it's grounded on this bound plane. All that drops down to a common set of ground rods. It heads inside the house and goes to the copper on the back. So everything in the shack, everything outside, all in the switching boxes, entry panels, everything is all bonded together to a single ground potential, towers and things like that. So I use dielectric grease. You can buy the really expensive stuff. I buy copper Permatex gasket stuff from the auto parts store. It's both conductive and it works great for stainless threads. It works anytime I have two things connecting together, whether it's copper to copper or steel to aluminum. I use that stuff to prevent the corrosion there. Good, Dave? Okay, so that covers a lot of the noise that, a lot of the noise that happens, basically QRN, or natural noise. But we also have QRM, man-made noise, coming from, so I live just out the southwest corner of Loveland, and if I'm looking, my antenna's looking to the southwest, what's right behind me? Loveland and Fort Collins. And when you start to build stations that are this low a noise, you can swing your beams around and listen, and you can just see the noise floor just climb when you're looking over the cities, and then as you look over the plains, it drops right back down. So there's going to be times when you can't get rid of, you have to deal with the noise. So one of the ways I do this is with a phasing system. I use the DX Engineering NCC2, which is if you look over on the right picture there, that is a little preamp with an it's about 8 or 10 foot little vertical antenna. It's basically a sense antenna. So if your main antenna and your sense antenna are picking up the same noise source, you can phase those together and cancel that noise source out so that only your main antenna is now not receiving the noise source. And it is amazing. You turn this phase knob, you can just turn it like this and down, and you can hear this monster noise come and disappear and come and disappear. So you can literally just crank out point sources of noise behind you or off to the side. Dick?
Okay, is this for like one strong source or is this more wideband?
It works for both. It works very well for the strong single source, but it works enough to be effective on wider band stuff as well. The trick is that both antennas are picking the same thing up. So that's why you don't need much of an antenna on your sense antenna, because typically the noise that you're trying to remove is loud and low. It's fairly local and loud, so it's easy to be picked up by everything. So I use that, a couple of those. I can phase between a pair of those verticals. I can phase between that and like a beverage on ground, or that and my shared apex loop, several different antennas depending on my thing. All right, so we've talked about efficiency, the antennas and tuning resonance. We've talked about noise and how to keep the lowest noise possible, getting the signals inside. So now it's time to talk about the automation side, putting this all together to make this fast. This is my current shack right now. I have basically two main HF stations. I have one on this side, which is the FTDX 5000. Over here, I've got a Yaesu FTDX 101. I have some amps in the middle. I've got a Elecraft KPA 1500 and a Yaesu VL 1000. Those are both solid state, legal limit and kilowatt amps. The step IR controller. This side of the desk over here is VHF, UHF, and satellite. And then, I've got rotor controllers and all the other accessories around there. It is set up as an SO2R, which is a contesting term for single operator 2 radios. I do not contest, really. It's not, I play in them once in a while, but that's not really my favorite thing. But I wanted an SO2R capable station, and I'll show you why as we come through the slides, why it's valuable for a DXing setup. My automation is driven this is the brains of the operation. This is a Microham Station Master Deluxe. The Station Master Deluxe is the station controller that drives all of the, it's got a bajillion inputs and outputs and figures things out. This is all the brains that keep you from blowing up gear, switching things that can't be done. I'm using the Station Master Deluxe because it works. It's a networked system. I have 2 of these, one on each radio. You can put, I think, up to 4 or 6 of these together. They make a Station Master, which does all the exact same functions for just a single radio and has massive functionality. But when you start moving into 2 or more radios, you have to go to the network system. Go ahead, Dave. The Station Master Deluxe is programmed initially by software. Very hard to see on the screen here, but what you see here is the station on top, and then all of the modules that do all the work down below, which we'll get to that in a little bit, but it's a bunch of relays and ADCs, serial interfaces, things like that to talk to all the pieces of equipment around your station. Go ahead. The first thing you do is you go in and you define your bands and you chop up, this is 1.8 to 2 megahertz. This is 160 meters. So I tell it all of the antennas that work on 160 meters. Then I tell it whether they're transmit, receive, or receive only antennas. This is what gives you all of the automation so that when you select a band, you can only select antennas that work with that band. So this thing will not allow you to, and it's hard to see up here, but what this is the 160 meter vertical, and below it is my shared apex loop. So this is the TX RX antenna, and this is an RX only for 160 meters. That's all I have on 160. As you go into 40 meters, I think that's here. Oh, this is 80 meters. So I have 2 transmit antennas on 80 and 1 receive antenna on 80. I can use any combination of those. Good. So each one of my stations, you got the radio down below. The Station Master is the controller. I have this piece here is called a microkeyer. This is my sound card interface, if you will. It's the audio in out. It's a keyer that handles all the CW keying. So if I want to use macros and things to send, that's what actually does keying of the radio. It does all of my level adjustments. This also handles the microphone input, and it handles all the PTT in and out for that particular radio. Done. So this is the other side, and it's other than a different radio, it's the same setup. So this one's got a Station Master, it's got a keyer, and they're all networked together, and it talks to the radio. Go ahead, Dave. In the middle of the desk is the amps. So I've got a KPA 1500 solid state, and then the VO1000 down here is a kilowatt Yaesu amp. So this is really the only way to do a no-tune amplifier is either go solid state or buy one of these amps that warms up in 10 seconds. Most tube amps, which are less expensive, take many minutes to warm up. But if you're at 3 in the morning, you rush down there. I went solid state so I could just turn them on and use them, and I don't have to tune them or anything else. They're instantly on the right band, and they're instantly warmed up. I also have a LP700 that I use for, this thing has 4 inputs, so I can monitor the power output and SWR in real time of whichever thing I'm using. I've also got a sensor between the amp and the radio, and then a sensor after the amp. And you can actually turn this, it does a triangle type display to show your amp linearity to make sure you're not splattering out and things like that. Just a little quick check there. The other thing I use, Microham gear is expensive, but I have found it is uncomparable. It is so bulletproof. The software is wonderful. The hardware is built very, very well. I believe they're a Latvian company, if I'm not mistaken. But these are the rotor controllers that I use. And the Arcos, You can use these with any kind of rotor you want. AC motors, DC motors, position pot sensors. You can tell it whatever the resistance of your pot is for your ranges. It'll do contact switch type rotors, so it'll drive everything known to man. And it's the reason I like it is it's got an Ethernet interface if you want to use remote. It's got serial interfaces. It talks all the protocols. But it's got some neat features, like you got some quick shots. I can go Europe, hit at 30 degrees, and it'll move the antenna there. It shows me a sun, and this is a live map on the front display of where the sun is lighting up the earth and where, which side's in the dark. And then there's a really neat little thing up here that shows you, since gray line is such an important thing with DXing, it shows you how many minutes and hours until the next or past the last gray line event. So this is, I think that says like, I can't read, is it plus 10 or something, plus, can you see it? After the sun has gone, well, the sun is up here, so it's probably counting down minus however many minutes or hours until our gray line. It's a neat, quick, easy visual to say, oh yeah, I gotta watch out because in an hour, oh here, plus 2. So this is right after sunrise. This is 2 hours and 32 minutes after our sunrise. So that's kind of a neat aspect of these rotors. Good. So I mentioned that the Station Master Deluxes were networked controllers. There's very little things plugged into that Station Master. It uses an RS-485 bus to talk to all these modules, and these modules are what's actually doing the automated work. Some of those have 10 relays, some have with a single common terminal. Some of those have 6 relays where you have access to both the pole, the normally open and closed. Some of these are A to D converters. Some of these are serial. Some of these are BCD modules that output or input BCD for band switching and things like that. But they're all networked together with an RS-485 bus, and they go out to the various pieces of my station to drive all of that. Outside, this is kind of the main routing of RF signals. I use a Ham Plus 2x8 switch. So there's up to 8 antennas connected on the bottom, and then the 2 that come back to the 2 radio stations inside. You can connect any 2 antennas to one each port on the left at any time. So, you can use 1-to-1, or at the same time 1-to-1, maybe 6-to-2 is connected. That's what allows the SO2R. It allows 2 radios. And by those modules inside are switching that around so that you can live switch any antenna to any port. Further, you can also select different antennas so that when you're in TX and RX, they're switching back and forth to different antennas. Good. So putting this all together, kind of got in a roundabout way, but I was talking about the 160 meter antenna, and I built this box to help move the resonance slightly up and down the band. So the Station Master talks to a relay box over here that switches these based on where you are in the band. Go ahead, Dave. So if I'm at 1.8 to 1.821 megahertz, relay 1 is selected out there. As I slide up the band, 821 to 832, relay 2 is selected. Slide up the band to third one, 3.2 to 4.8. I don't know 4.8. So this is how, as I'm moving my VFO up and down, it's out there clicking the right relay to select the taps on that coil. My antenna it doesn't need tuning. The resonance is following me up and down the band on that 160 meter antenna, which has a narrow bandwidth. Don't need a tuner. It's always perfect wherever I am. In those little segments now, like 80 to 821, if you looked at your antenna on an analyzer, you see the nice curve. That curve is just moving. And so from right dead center in there at 811, and the SWR is 1-to-1. On 801 to 819, for example, it might be 1.3 to 1. But that's how I'm automating a narrow banded antenna with this, so I don't have to use a tuner. When you start getting this level of things, there comes a point in which you have to draw it all out so you can keep track of what's going on. Down here I've got my main 2 radios, the station masters are there. I have these, those are the amps. Then I have these 1x2 switches that allow me to, because both of the radios have a TX RX port and an RX only port, by going to a 2-to-1 before I go to the 2-to-8 switch, I can now run up to 4 antennas to a single radio all at the same time, so I could switch between TX and RX and be using one or 2 antennas in each one of those modes all at the same time without having to change anything. It just senses it and does it. This is the only manual part of the station. So most of that stuff that comes in, I have surge suppressors, lightning suppression at the entry point of every cable, but I have an additional point here. I use these alpha delta switches, which are center off grounded. This just gives me a little bit more flexibility to test things from inside when I've got all that switching outside, and it's an additional ground point. So I've got a lot of manual switching inside that just gives me a little extra safety and a little extra flexibility. All right, so now you see we've talked about the noise, the efficiency, the optimization. Now we've talked about the automation. Now we can show you how quickly we can put all this to use and what some of the use cases are for it when you're DXing. On the Station Master, I mentioned you program it such that this is currently on 40 meters. It is currently receiving on my shared apex loop receive only antenna. It's transmitting on my step-by-R, but I've got 3 antenna choices available below. Good. I can, with the press of a button, I can select on either my TX side or my RX side or both horizontal or vertical polarization. So if I'm hearing something or I'm not hearing something, I can flip and check another antenna just that quick. And if they're not hearing me, I could flip and change and transmit. So I might be receiving on vertical and transmitting on horizontal. And I can hear them, they can't hear me. Well, the next go around, I can flip and transmit the other polarization and see if they hear me better. So I don't have to think about it. I know whatever's there is going to be there, and it's going to be tuned and work. So I can check things like that very quickly. I also have the ability to do long path, short path, and skew path very quickly. This is the shared apex loop controller. It's got a flip button. It's receiving in this direction. You flip it, it instantly electronically listens the other direction. That's like a 1/10 of a second kind of a switch. The step-by-R has a 180 button. Remember I mentioned those tapes in there? It'll move each one of them and turn it into an antenna looking the other direction without rotating that big mass around. So Bouvet, if anybody is familiar with I can't remember I think it was number 2 or number 3 on the most wanted list. I think it's still there. It's a glacial pile of rocks in the Antarctic that nobody ever goes to, and they were on the air in January of last year. I was listening for them on 17 meters short path, the direct path, Great Circle path. Couldn't hear them. 0 signal. They had 100 watts in a wire on that side. There was a little bit of a debacle in that, but I clicked the 180 button on the step-by-R, flipped the antenna around. It takes about a second or 2 to flip it, and they were about an S3. So couldn't hear them at all forward, but the long path around the world, I could hear them S3, and instantly they just jump out of the noise. So, go ahead, Dave.
Were you able to work them then?
Yes.
Dick made the comment to me, what's skew path? And I said, too long to answer.
Oh, yeah.
So maybe you could.
Yeah. So skew path. The question was, what's skew path? So short path is the shortest great circle route between 2 points on Earth. Long path is exactly 180 degrees. The longest path between 2 points on Earth, the other direction. Skew path is often used, especially over the poles. With Aurora, the top of the Earth and the bottom of the Earth tend to be the most affected by ionization and things like that, the magnetic fields. So sometimes they will bend the signal just a little bit, maybe 10, 20, even 30 degrees. So if you're pointing straight at them, you may not be able to hear them, but if you move your antenna 30 degrees to the right, you might be able to hear them real strong. That's skew path. So you're just following the bending of the path. Now, I mentioned the SO2R aspect, the single operator 2 radio. This is how I use it for DXing. If you have ever, I don't care if you're, this is FT8, but it works the same for absolutely anything. The QSB is especially the biggest one. That's where your signal fades in and it's gone, and it fades in and it's gone. That QSB can be very short. It might be 3-4 seconds. It might be 2 minutes. So it varies. One of the things I learned after building this station is that during those QSB fades when the signal disappears, you might actually hear it in the other polarization. So by doing this and by putting with my controllers, I can put one radio in one side of my headset and the other receiver in the other side, having all those antenna switchable patterns. I might actually be able to hear, as I'm calling him CW or FT8, doesn't, whatever, sideband, and he fades away, I hear him move from one ear to the other. Everyone else lost him for 30 seconds or 2 minutes, but I hear him. He's just over here in this receiver because I moved. His signal is now better on the other antenna. So I can listen to both polarizations and across multiple antennas at the same time. Same band or different band. You can actually run WSJTX if you are an FT8 person. You can run 2 full copies at the same time talking to 2 different radios, but they log to the same log. So there's been times when I've got 2 of these running, and I'll call, and the DX will give me a report back. But the QSB has faded gone, and he doesn't hear, I don't hear his like RR73, but it comes up on the other side. So I can just go log, bam, and I'm done. So even though I listened to it, I listened to half the report on one radio and one antenna and half the report on the other, I completed, and I didn't, not only did I complete, but I gave up the time slot, the bandwidth, the RF spectrum there for someone else to use because I finished it quicker. So that's been a really big boon for working real weak ones. So the last piece here is how do we make these changes very quickly? I use DX Lab Suite for my station control and logging. It's a free suite of software. It's very well supported. It's not pretty, and it's very complicated because it does everything. So it's got a big learning curve, but it's super flexible if you're willing to take the time to learn it and use it. I can actually, if I come down here and say, and I don't have spot collector running on here, but I could, for example, if I had the spot collector running, which is another piece of this, I could say, there's H40WA. I could double click on that, and it will take the radio to his reported frequency. If a split was reported in the spot, it'll set my radio on split and change my transmitter that far up. It selects the right antenna, it changes the radio band, it moves the rotor to that short path direction, switches my amps and my bandpass all from that single click. Station's done, ready to go on that. Then from there you can fine tune and tweak things. This is the SO2R controller that I use. This is the thing that allows me to hear things in each headset differently. I can, with the few little buttons here, I can actually hear, I can set it, you can do just about anything. You can say I want receiver right and right ear, receiver left and left ear. I can say I want to hear both receivers in both ears. This is doing is switching my audio, and it's also switching my PTT switches, whether I use a handset, the foot switch, or whatever, it's steering it to which radio I'm transmitting on. Good. I use Radio Sport headsets, and this red button right here, right on the headset, is a PTT switch, so that's an option. I also use these hand switches. That's what I use most of the time as a PTT. Go ahead, Dave, switch. And then I have a foot switch down on the floor. All of those are paralleled, so whatever you use, the quickest you can get to, you can use the PTT button. Dick?
What's the name of that headset again?
Radio Sport?
Radio Sport?
Yeah, it's Arlen Communications. He ran race cars for a long time, and he custom built headsets for race cars, and then he's moved into the ham set. I don't think you'll find a more comfortable headset. If you look at every DXpedition out there, they're all using Radio Sport because they can wear them for 8 hours at a time and not get fatigued. They're phenomenal. Yeah, they're phenomenal. So this is another speed piece. This is one of the reasons I like the Arco rotor controllers. Yes, I can click in the computer and do that, but say I rush down, maybe it's a CW contact, I don't have time to load all the computer stuff. And I know one of my friends sent me a text and said, hey, they're on XYZ. I don't know what the bearing is, the heading is, without looking it up. You can just touch this and say, they're on Tomotu. I just hit H40, DXCC, and it instantly tells me the short path is 261. If I touch that again, it goes to the long path, and I hit go, and the rotor goes there. So the rotor knows where I am, and it knows where all the DXCC entities around the world are. It also can do it for Workdahl zones, ITU zones, or grid locators. If you're a VHF contest hunter, I can type in DN71 go or DN71 LQ go, and it'll just send the antenna right to that path. So that was one of the things I ended up fumbling around trying to figure out what's my bearing, to the DX, and that was a quick way to solve it. So let's walk through what happens when I press a button. So here's one of my radios. I touch 40 meters. What happens? Right? The first thing that happens is the station master picks up that I'm on 40 meters. It only allows me to select for TX and RX antennas that work in that band. Since the SAL is selected for RX, it's an omnidirectional antenna. Since the STEP IR is selected for TX, it has connected to the right relay boxes. It has read from the rotor controller that I'm at 325, and that's about that direction, and it's got the frequency there. I can quickly select. It talks to the switch, and it flips those antennas in and connects all those antenna paths through the amplifiers back to that radio. It talks to the rotor controller and either reads the direction and or sends it there and repeatedly is telling me the updates until it lands where it's going. It talks to the amplifier and it band selects and it brings it out of standby into operate mode, ready to go. Band pass filters, when you're running any kind, it doesn't even matter if you're running 100 watts. If you're running two radios near each other, even on opposite bands, you need band pass filters. So it selects the right band pass filter for each radio and puts it in line. And then this is the important part. On the other radio, if you happen to want to use the same band or the same antenna, it locks it out and says, sorry, can't do it. The other radio is using that antenna right now. So that keeps you from, for example, if this radio was over here running FT8 and you're waiting on a transmit cycle and you're like, oh, CW came up, and you switch it over here, the next 30-second cycle and the 15-second cycle, and it goes into transmit, that prevents it from transmitting into the radio you just flipped over to the band. And then you work your all-time new one or your band slot. So that's kind of the genesis behind all this craziness. Does it work? It does work. These are probably two of my most proud contacts out of all the places I've worked around there. 3Y0J was that Bouvet Island expedition. They had major problems, couldn't get most of their people on the island, and they couldn't get any of their amps on the island, none of their high power generators. They literally ended up with, I think, 4 guys working with 2 radios on a 5-gallon bucket at 100 watts to a dipole stretched out there.
2,000 watt generator to run.
Yeah, 2,000 watt generator to run what was there. They were very, 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 very hard to work. They only ended up making, I can't remember, I mean, instead of 100,000 contacts, I think they made like 2,000 contacts worldwide. This one, believe it or not, this one's not all that hard to work, but this one is this one's special to me because Amsterdam Island is the furthest piece of land you can work from Colorado on Earth. It is antipodal to Lamar, Colorado. So it is from Lamar, Colorado, which is this, so what's the interesting thing about that? What's the beam heading to an island like that? It's anywhere. It's all, in reality, it's not, right? There are some, because the Earth is not perfect sphere, but yeah, it's any direction because it's all about the same distance to the other side. So being the furthest place on Earth you can work another piece of land, that one was a fun contact. And yes, I have proof that I did both. So this was 17 meter CW long path, and this was 30 meter CW short path to those 2 islands, which I guess short path and long path is really the same thing for FT5ZM. But what I did is I filled the whole, so it comes in a package that's about, 12 or 14 inches. I filled it with water and pinched it off, and I froze it. And then I wound it on a PVC form that kept the walls from collapsing, and then you just thaw it and let it dry out, and it formed perfectly. So yeah, there was no issue there. And then
on insertion loss?
So it's, I never did measure that. They're really low. So one of the things that I didn't mention it in this presentation, but I have done a ton of research on is the trick to low insertion loss and efficiency in an impedance transformation device is using the right material. So that unknown is wound on FT1 161 type ferrite. So using the right iron core or ferrite core and using the right material so that you keep your heating under control and everything else, that's the magic behind doing it. I didn't measure it. I have the ability to measure it, but I haven't measured it. It's really low. So, other questions? Yeah.
Just real quick, you got a question. Just a question. How long did it take you to put this together?
10 years. So, yeah, right. So it's an evolution, just like everybody's station, and so I've slowly been working on it, and the 10 years is that's inclusive of amount of free time I have, the research time, the money that you put into it to spread that out. So I could replicate that station in a month, but I've got about 10 years of changes in there. 10 years ago it was a vertical in the backyard. Dick?
For a station like my own, which is, immersed in a sea of wall warts and whatever in a subdivision, what would be the first couple of steps you would recommend as far as getting the common mode noise under control?
That's an easy one. Go to Palomar Engineering. Palomar Engineers. If you search for Palomar, you'll find it. They sell. So he's really, really talented he understands the aspects of ferrite and iron core and all that stuff, and they sell really nice kits. If you say, I have a ICOM 7300, you can buy a 7300 kit that's got all of the right pieces for that radio, every cord in and out of there. Those kits help a lot. That's a really great starting point. That, and put 1-to-1s on both ends at the antenna, and put another one as it comes into the house. That's my best recommendation as a starting point.
Okay, thanks, because I've got the Palomar kit on, and the more expensive unit that goes at the radio, I think it's a 1-to-1. They have just like wind the coax around a toroid. Then they've got another unit that actually just has SO239s on it. I definitely noticed a fairly 1 or 2 S unit drop in the noise just with that one unit. So,
Yeah.
so now I guess next step's going to the 1-to-1s.
Yeah,
Thanks.
so that brings up an important point about ferrites. If you looked through some of my slides, occasionally you saw snap-on ferrites, and then you also saw toroid rings. The important thing to remember about the choking effect is that if you use a ring, if you have the room and cable flexibility, if you use a ring, every time you pass the core, the cable through the core, it 4x's the effect of the choke. So in other words, one turn through a ring would take 4 snap-on beads. 2 turns would take 8 snap-on beads, and so it exponentially changes. The passing through a toroid ring is far more effective at reducing things than the snap-on beads. If you're fighting something small, the snap-on beads are great, but if you've got a fairly strong presence and things like that, the toroids are far more effective. Anything else? Oh, Gabe?
For someone in an even more noise-dense environment, in an apartment, worse than he has, what would you recommend? Especially for like power, because I had a choke on my power cord, but it wasn't doing as much anything for me. So
Yeah. So, the environment gets more and more challenging as you go through there, but there's a few things you can do. So MFJ makes a much less expensive version of that phase canceller that just has a whip on the thing. Yeah, I think Joe's got one. That can be effective at tuning out some of that stuff. The other thing that you could consider doing is loop antennas tend to be more effective at rejecting noise. You could either look at using a loop antenna in your apartment as a receiving antenna, or potentially running a wire around the ceiling and using that as a receive-only antenna. Just some ideas. It becomes really tough. That's a hard environment to, where you've got massive amounts of energy that you're trying to hear through.
Hi, I have a Newham question, and maybe
Okay.
that you can answer this or not. If you're a Newham that's focused on and motivated through DX, knowing what you know now, where do you start your knowledge arc, and where would you see your knowledge arc kind of going now that you can look back?
The first thing you got to do is join Mile High DX Association.
You have the whole board right here between him and I.
No, as far as where do you start? So, I say the Mile High thing in jest. However, that it's groups like that where you can get connected with people. One of the best ways to learn through this stuff, if you are just amazing at a book learner and can understand that stuff, there's tons of resources out there, but not many people are, right? This is so, and there's also, there's a difference between textbook and real world it can be so extreme in this world. The best thing you can do is to try to basically get an Elmer, somebody that's got experience doing this already, especially if they live fairly close-ish to you, so that you can, go back and forth between stations and ask these questions of that. That's really the best option. The other half, I will tell you, go in your backyard and try some things. You don't need hundreds and thousands of dollars to experiment with things. You can set up, go out and buy electric dog fence, the invisible fence wire. You can buy hundreds, 500-foot spools of that for like 16, 17 bucks. Go out and try different, make low dipoles, just experiment with these types of things, and you'll see how they react to each other. They don't have to be 50 feet in the air and full size for you to see the difference between them. But those are the two best, pieces I can give you is try to find an Elmer, and, the local clubs are a great way to do that. Join them and throw a message out on the reflector and say, hey, I want to learn about this, or I've got this problem, and get connected with people, and then experiment.
With your surge arresters at your entry points into the house and your alpha delta switches that are center ground, if you're home and there's an electrical storm approaching, do you still find yourself disconnecting coax from the back of the radio, or do you not?
I never do. I honestly, I think a storm would come and go by the time I unplugged all that many pieces of wire, for one. But I will tell you this. I've taken 2 direct lightning strikes. When I say direct, I mean at least part of the bolt hit the antenna directly. It was maybe not the entire. So I was sitting on the back patio one afternoon, and lightning hit the power line about a mile down the road. Well, it stayed in the power line until my house, and then it exited and hit 2 of my verticals, and it hit my tri-bander, and then as soon as I restarted my heart from sitting 50 feet from all of that happening, it burned out some stuff out at the antennas. I smoked some coils there were some DC grounding coils in the verticals and stuff that charcoaled, but the alpha deltas, they welded into little briquettes. The gas tubes shorted and literally they melted into tubes. I had no damage inside. I was lucky, right? I mean, that's to take that kind of a hit. The second one happened this past summer. We had if you ever heard the term bolt from the blue, there wasn't a cloud in the sky any direction you could see, and I had a full bolt hit. It hit my ground plate, the 80 meter vertical, just, 12 inches from the vertical itself. Which also is another good example of it does not always hit the highest thing. If you've done your grounding right, doesn't matter. It may hit anywhere. It hit the ground about 12 inches from the antenna, and it took a giant chunk out of the ground radial plate. It just looked like it had been cut with a plasma cutter. And again, the arc plugs welded shut and prevented any damage. So, no. I have spent an amazing amount of time trying to make sure all my grounding and bonding are done right. It's about time for grounding bonding talks and nets and stuff, right? Isn't it the time of the year for so I do not disconnect my coaxes. Personal preference, there's a risk. There's always a risk, right? There's a risk with them disconnected too. Well, is there anything online? Any questions from online? I wasn't watching to see if anybody. Dave probably was. Well, thank you very much.